Hi, this is Mrs. Sebastian with Proportional Relationships, and this is on Study Island, Tennessee State Standard 8 EEB5. Matilda and Catherine went on different road trips over spring break. The equation below represents the number of miles that Matilda drove in X hours. So Y equals 61X. Okay, let's see. And that means 61 miles per hour is what Matilda drove, because that is what our slope represents. The table below shows the number of miles that Catherine drove in X hours. So it looks like it's 116 miles every 2 hours. So if I divide that, 116 divided by 2, it would be 58 miles per hour. So I would say they want to look at which one traveled the greater speed. So that would be Matilda. You could also plug in numbers and say, okay, after 4 hours, we know that Catherine drove 232. You could plug that into the equation they gave you. And Y would equal 244 miles. So you can tell that that is a longer distance than Catherine drove. So Matilda must have driven faster. Anne and Kylie worked over summer vacation. The equation below represents the amount of money that Anne earned after X hours of work. Okay, so she worked 1 hour. That would mean that she earned $10.75. So that's the unit rate. And she earns $10.75 per hour. So let's look at Kylie's. So Kylie works 4 hours and earns $63. Okay, so 63 divided by 4 is what I want to do to find out how much she makes per hour. So 63 divided by 4 tells me that Kylie earns $15.75 for every hour she works. So let's see who earns more. So Anne earned more money, they earned the same amount of money, or Kylie earned more money per hour. So per hour, Alice will be serving punch at an event she is hosting next month. The graph below shows the number of servings based on the amount of punch available. What is the unit rate of the graph? So what I do is I can pick any point on here. Because it is at 0, 0, it is a proportional relationship, which means it starts from 0. And it goes up the exact same amount each time. So I could pick here 4 and then 20, or I could go to 8, 40. The reason I do this is because I want to look for somewhere that crosses the corner of my grid so that I can tell that that point is exactly that. I mean, we could even pick this top one here. I've got 20 servings for every 100 ounces. Okay, and they have it as fluid ounces per serving. So I'm going to put the 100 on the top because that's how many ounces there are over 20 servings. And I just need to simplify that. So 100 over 20 gives me 5, and that is ounces over the number of servings. So I look for the one down here that says that, and it would be D. I could have picked any point on here. So if I picked this one right here, okay, that point is at 1260. Do the same thing, 60 divided by 12. And that still gives us 5. So it still would be 5 ounces per serving. Candace and Peter are ordering pizzas for upcoming parties from different pizza places. Candace is trying to decide how many pizzas she wants to order from Pizza in the Sky. If she orders 2 pizzas, it will cost her $11.98. If she orders 3 pizzas, it will cost her $17.97. Okay, Peter created a table to determine how much X pizzas would cost from Mike's pizza place. Okay, so I'm going to start by trying to figure out how much each pizza cost. And I can do that 2 different ways. I could say $11.98 divided by 2. Or I could see what the change is if I'm going up 1. And I can figure out that I'm going up $5.99 here. So I could say, okay, if I do 4 pizzas, that's going to be $23.96. So notice that both Peter and Candace have the exact same amount per pizza. So they will pay the same price per pizza. While at the dog park, Coral observes the proportion of German Shepherds to Golden Retrievers is 1 to 2. So for every 1 German Shepherd, there are 2 Golden Retrievers. Which graph represents this proportion? So the first thing I'm going to do is I'm going to look for the labels on the axis, and I see that the x-axis is Golden Retrievers. Remember, that one was 2. And German Shepherds was 1. So I'm going to put this on each one of ours. Just so that it reminds me. So I'm going to look for the point 2, 1. And see which one of my graphs says that. So if I go over to 2 and up to 1, that's not on my graph. So that's not it. I go over to 2, up to 1. Okay, X does that. Let's check the next one. 2, 1. That's not it. And over to 2, up to 1 German Shepherd. That's not it. So the one that does that is X. Rebecca recorded the amount of rain last Wednesday. At what rate did the rain fall? So I'm looking for every 1 inch or 1 centimeter for every 1 hour. So I need to know how many centimeters per hour. So I need to know the slope. If it starts from 0, 0, I'm looking for a spot where I can find where it crosses exactly. Let's see. Does cross exactly right here and right here. Right there. Okay, so I could pick any of these and I could say, okay, I'm going to rise 1, or this is 1/2, because each one of those lines is 1/2, and run 1. So 1/2 centimeters per 1 inch, or per 1 hour. Okay, so that one I would choose C. Okay, I could also do it by picking any point on here. One I see is 3, 1.5. I could pick 2, 1. I could pick right here 1.5. And every one of those shows me that it is 1/2 centimeter per hour. Ben and Angela were riding their bicycles one afternoon. They kept track of their own cycling rates as shown in the graphs below. So determine each rate and then complete the comparison. So I'm going to look at Ben's cycling rate first. So I go over to 1, and I'm going to go up to where it meets my graph. And it meets right here, and that is at 15. So his was 15 feet per second. Angela's rate, we're looking at hours. If I go up, that is 12 miles per hour. So I want to know how many feet per second someone is quicker. So we need to change Angela's to feet per second. So we have 12 miles, and I'm going to do a conversion. So I'm going to say, okay, how many feet are in a mile? That would be 5,280 feet over 1 mile. So that means there are 5,280 feet per 1 mile. And then I've got to change the hours to minutes. So we're currently in hours. And I want to change it to minutes. Oh, wait just a second. Let's do that conversion here in just a moment. I'm going to go ahead and do the first conversion where I multiply 12 times 5,280. And I'm doing it this way because I don't want to get too many steps all together where it kind of gets confusing. So let's do 5,280 times 12, and the miles will cancel each other out. So I'm going to have 63,360, and this is now feet per hour. Now I need to change my feet per hour to feet per minute. So if I've got hours on the bottom, then I'm going to put 1 hour on top. And how many minutes are in 1 hour? That would be 60 minutes. And I've still got to change it to per second. So minutes are on the bottom now. Okay, but I need to change that to per second. So I'm going to put 1 minute is how many seconds? That's 60. So now I will be left with our feet per second. So 63,360 divided by 60 divided by 60. And that does give us 17.6. Okay, so 17.6. So she was 2.6 feet per second quicker. That's Angela. The cheerleading squad is creating banners for an upcoming pep rally. The proportion of length to height of the banners must be 3 to 1. So length 3, height 1. Height 1, length 3, length 3, height 1. Notice that some of these are set up just a little differently. Okay, which graph represents this proportion? So I'm going to go to where my height is 1, my length is 3. Okay, so W looks pretty good. Let's look at X. I want to know my length 3, my height 1, my length 3, my height 1, so this one can't be it, and my length 3, my height 1. Okay, so the proportion of length to height is 3 to 1. So when you see that, the top of the proportion is your Y value. The bottom of your proportion is your X value. So if it's 3 to 1, you want the 3 to be your Y value.